This conference will now be recorded.
So today we'll be discussing what is melting point, what is boiling point, what are the different intermolecular forces. We need to study for ionic and non-ionic compounds. So how they are going to influence these physical properties. So first is melting point. So what do you mean by melting point? Nikita, what do you mean by melting point?
Ma'am, the temperature at which a substance
I
will
am
melt.
asking Nikita.
Sorry, ma'am, sorry.
Nikita, are you there? If you are not responding, your
Yes,
attendance
ma'am.
will not be recorded. Yes. Tell me what do you
Yes,
mean by
ma'am.
melting point?
The temperature at which a solid changes from solid to liquid state.
Yes. Solid state to liquid state. The temperature at which
Liquid state.
the substance will change
The
from solid
substance
state
is
to liquid state.
liquid state.
Yes. So you can see. So in a crystalline solid, the particles acting as structural units, ions, are molecules. So these are arranged in some very regular symmetrical way. There is a geometric pattern repeated over and over within a crystal. So you can see here the first slide in the first picture, solid, how it is arranged, very tightly arranged.
Ma'am, no slide is displayed, ma'am.
It's not displayed.
Ma'am, we can't able to see.
Yes, ma'am. No
Okay.
slide is displayed.
Okay. I'll share it. Now,
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
so this you can see solid, how the structure is arranged. Very regular, symmetrical way. There is a geometric pattern repeated over and over within a crystal. So this is in solid. So when you supply a heat, so that is temperature. When the temperature is raised, what happens? What happens when the temperature raises?
Solid melts into liquid.
The particles get broken down.
Kinetic energy of the particles increases.
Intermolecular
Kinetic energy
spaces
of the
increase.
particles increases.
So melting, the change from
It expands. I mean, your voice is echoing.
yeah, why I don't. I'm also getting. All of you mute. Yeah. So melting is the change from the highly ordered arrangement of particles in the crystalline lattice to the more random arrangement that characterizes a liquid. So you can see solid, how the structure is, and when you start heating, how the molecules will move, ions will move, and you can see in liquid it is not regularly arranged. They are going to move apart. So melting occurs when a temperature is reached at which the thermal energy of the particle is great enough to overcome the intracrystalline forces that hold them in position. So they will be having some intracrystalline forces. So that is overcome when the temperature is increased. So melting is the change from the highly ordered arrangement of particles in the crystalline lattice to the more random arrangement that characterizes a liquid. Melting occurs when a temperature is reached at which the thermal energy of the particles is great enough to overcome the intracrystalline forces that hold them in position. So, first example we'll take ionic compounds. So, example for ionic compound, sodium chloride. Yesterday we discussed. So, think that positive is sodium and negative is chloride ions. So an ionic compound forms crystals in which the structural units are ions. So solid sodium chloride example is made up of positive sodium ions and negative chloride ions, alternating in a very regular way. So you can see this first structure, alternate. You have positive ion and negative ion, that is sodium and chloride ions. Surrounding each positive ion and equidistant from it are 6 negative ions. So one on each side of it, one above and one below, one in front and one in back. Each negative ion is surrounded in a similar way by 6 positive ions. So see here how it is arranged, one in front, one in back. One below, one above. So each side like this, each positive ion is surrounded by negative ion. Similarly, each negative ion is surrounded by positive ion. So we can't say or differentiate that proper which sodium chloride ions it is. A particular sodium ion does not belong to any chloride ion. It is equally attracted to 6 chloride ions. And the crystal is an extremely strong, rigid structure since the electrostatic forces holding each ion in positions are powerful. They are very powerful. These powerful inter-ionic forces are overcome only at very high temperature. So, what is the melting point of sodium chloride? Anyone has observed? Kushal, you are telling something?
Ma'am, no, ma'am.
So, anyone has seen what you use common salt in your home? At what temperature it will melt? Any idea? It is very high, very high temperature. It is 801. Yes, 801 degree Celsius. So imagine how strong the intermolecular force are in the ionic compounds. So at the melting point, the regular arrangement of ions is broken down and the ions become free to move. So although the ions are still close together, they can move independently. So the molten sodium chloride can conduct electricity. So you can see here, ions are held in the lattice by the strong electrostatic forces. So you need a very high energy to separate the ions. So the ions have more freedom and the sodium chloride becomes liquid. So the temperature required is more than 800 degree Celsius. So similarly, the crystals of other ionic compounds resemble crystals of sodium chloride. So they also have ionic lattice similar to sodium chloride, but the geometric structure may be different. So these ionic compounds do have very high melting points. Most of all the ionic compounds will be having high melting points. So some molecules will contain both ionic and covalent bonds. Can you give me one example? The compound which contain both ionic bond as well as covalent bond. An example for compound which contain both ionic and covalent bond. Anyone?
Ma'am,
Sodium
sodium
nitrate.
nitrate.
Yes, sodium nitrate.
Calcium carbonate.
Right? Calcium carbonate. So all these are having covalent as well as ionic bond. We'll discuss regarding potassium nitrate. So this potassium nitrate is made up of potassium ions and nitrate ions. So these are potassium and nitrate are joined by which bond? Ionic bond. But the oxygen and nitrogen atoms of the nitrate ions are held each other by covalent bonds. So the physical properties of compounds like these are largely determined by the ionic bonds. So potassium nitrate has physical properties related to sodium chloride. So potassium nitrate also melts at very high temperature. So next is non-ionic compound. So non-ionic compound, here the atoms are held to each other entirely by covalent bonds. Here only covalent bonds are seen and forms crystals in which the structural units are molecules. So in this, the forces holding these molecules to each other that must be overcome for melting to occur. So these intermolecular forces are very weak compared to the forces holding ions to each other. So ionic compounds will have ionic bonds that is very strong, but non-ionic compounds will not have the such strong intermolecular forces. They will be having very weak compared with the forces holding ions to each other. So to melt sodium chloride, we must apply enough energy to break ionic bonds between sodium and chloride. To melt methane, we may not need so much energy. So the energy required to break methane molecule is very, very less. So you can see the melting point of methane is minus 183 degree Celsius. So whereas the melting point of sodium chloride is more than 800 degree Celsius. You can see what a huge difference of temperature, your melting point you can see. So you can see here ionic solid strong electrostatic interaction, sodium and chloride ions, whereas molecular solid, that is methane molecule, you have weak intermolecular forces. Next is intermolecular forces. So what kinds of forces hold neutral molecules to each other? So when you have a charge, you can say it is ionic. When compounds are neutral, they do not have any charge. So where does the force come to hold them? So there are two kinds of intermolecular forces. One is dipole-dipole interaction and the second is van der Waals forces. So like interionic forces, these forces will help to be an electrostatic in nature involving attraction of positive charge for negative charge. So that is dipole-dipole interaction and van der Waals forces. We'll see one by one. So what is dipole-dipole interaction? Dipole-dipole interaction is the attraction of the positive end of one polar molecule or the negative end of another polar molecule. Example, if you take hydrogen chloride. So hydrogen chloride is one molecule. So how the dipole-dipole interaction can be seen in between the molecules, two different hydrogen chloride molecules. So you can see here hydrochloric acid HCl. So this is covalent bond and they'll be having some partial positive and partial negative charge. Why it is having partial positive and partial negative charge? Manisha? Manisha, are you there?
Yes, ma'am.
Yes, what is, why you are getting this partial positive and partial negative charge here? Yesterday we
Because
discussed
of
this. Because of presence of
intermolecular attraction.
So this chlorine is highly electronegative. So when this is present, what it does? It will pull the electron towards it, and it is highly electronegative. Hence, there is partial negative charge on chloride ion. And hydrogen, since it is losing the electron, it is having partial positive charge. So HCl, this molecule and this molecule will be having some interaction through this intermolecular attraction. You can see here the chloride ion, which has a partial negative charge, and the hydrogen of another molecule have a partial positive charge. So these two will attract each other. So this is nothing but the dipole-dipole interaction. So here what happens? The attraction of the positive end of one polar molecule or the negative end of another polar molecule. So between two molecules it will be acting. So as a result of dipole-dipole interaction, polar molecules are generally held to each other more strongly than are non-polar molecules of comparable molecular weight. So this difference in strength of intermolecular forces is reflected in the physical properties of the compounds. So this will affect the physical properties like melting point and boiling point. So a strong kind of dipole-dipole interaction is hydrogen bonding, in which a hydrogen atom serves as a bridge between two electronegative atoms, holding one by a covalent bond and the other by purely electrostatic forces. So when hydrogen is attached to highly electronegative atom, what happens? The electron cloud is greatly distorted towards the electronegative atom, exposing the hydrogen nucleus. So the strong positive charge of the thinly shielded hydrogen nucleus is strongly attracted by the negative charge of the electronegative atom of a second molecule. So you can see here. So this hydrogen, due to thin shield of positive charge, it is going to attract the negative charge of other molecule. So it is much stronger, however, than other dipole-dipole interactions. Compared to other dipole-dipole interactions, the hydrogen bonding is very strong. Generally, hydrogen bonding is indicated in formulas by a broken line. So when you see this broken line, this indicates that this is the hydrogen bonding. So for hydrogen bonding, both electronegative atoms must come from the like that, it will be there. So only hydrogen bonded to one of these elements is positive enough, and only these three elements are negative enough for the necessary attraction. Yes.
Ma'am, can you repeat what you said? Actually, your voice was cracking, so I could not keep the contents.
So for hydrogen bonding, what is important? Both electronegative atoms must come from the groups, like either it should be a fluorine, oxygen, or nitrogen. So only hydrogen bonded to one of these three elements will be more positive enough, and only these three elements are negative enough. What are the three? That is fluorine, oxygen, and nitrogen. So these three.
Thank you, ma'am.
For the necessary attraction to exist, this is important. And these three elements will have their special effectiveness to the concentrated negative charge on their small atoms. So whatever this partial negative charge is there due to this highly electronegative negativity of the atoms.
Okay, ma'am.
So here, if you take an example of water molecule. So what is this bond? Oxygen and hydrogen, what type of bond it is? OH. It is covalent bond and it is polar molecule. So polar, they have partial positive and partial negative charge. So this is intramolecule. Now intermolecular. So now between two water molecules is intermolecular. So what is this bond? This is purely hydrogen bonding when it is indicated with the broken lines. So there must be forces between the molecules of a non-polar compound. We just discussed about polar. Now we discuss about non-polar. So in this case, each compounds can solidify. Such attractions are called van der Waals forces. The existence of these forces is nothing but van der Waals forces. So example, if you take a methane, so you can see a methane molecule. The average distribution of charge is symmetrical, so that there is no net dipole moment. So here there is no dipole moment here because it is why there is no dipole moment in methane molecule?
charge is symmetrically distributed?
Because we don't have a strong electronegative atom. Carbon and hydrogens both are having equal dipole in dipole interaction, and so there is no net dipole moment. However, the electrons move about so that at any instant the distribution will probably distorted and a small dipole will exist. Very minute dipole may exist. This momentary dipole will affect the electron distribution in a second methane molecule nearby. You can see here very less. We have indicated with 2. The negative end of the dipole tends to repel electrons and the positive end tends to attract the electrons. The dipole does includes and oppositely oriented dipole in the neighboring molecules. So positive will attract the negative, negative will attract the positive. So there some attraction will occur that is very weak. This weak intermolecular attractions are nothing but van der Waals attraction. Although this momentary dipoles and induced dipoles are constantly changing, the net result is attraction between the two molecules. There is only attraction. So these van der Waals forces have a very short range. They're at only between the portions of different molecules that are in close contact. That is between the surface of the molecules. You can see only on the surfaces. It is not strongly inside. Only on the top there is a attraction. So methane has no net dipole. At any one instant, its electron density may not be completely symmetrical, resulting in a temporary dipole. So these are temporary dipoles. This can induce a temporary dipole in another molecule. This is nothing but van der Waals forces. So this will have very short range. They are at only between the portions of different molecules that are in close contact. That is between the surfaces of molecules. So understood what is melting point, what are intermolecular forces. Any doubts here? Yes. No doubts. Shall we move to boiling point? Next is boiling point. So what is boiling point? What is the definition of boiling point?
Ma'am, the temperature at which the liquid component turns into vaporized form.
Okay, but the exact definition is the boiling point of a substance is the temperature at which the vapor pressure of a liquid equals the pressure surrounding the liquid, and the liquid will changes into a vapor. This is the definition of boiling point. So the boiling point of a liquid varies depending on surrounding environmental pressure. So the particles in a liquid are arranged less regularly and appear to move about than in a crystal. Each particle is attracted by a number of other particles. So it will not be as rigid as solid, how the atoms were arranged. But here it will be little less regularly arranged. Boiling involves the breaking away from the liquid of individual molecules or space of oppositely charged ions. This occurs when a temperature is reached at which the thermal energy of the particles is great enough to overcome the forces that hold them in the liquid. We'll see how this boiling point in ionic compounds. In the liquid state, the unit of an ionic compound is again the ion. Each ion is still held strongly by a number of oppositely charged positive ions. Again, there is nothing we could properly call as a molecule because it will be moving. So a great deal of energy is required for a pair of oppositely charged ions to break away from the liquid. Boiling occurs only at a very high temperature. The boiling point of sodium chloride, for example, is 1413 degrees Celsius. In the gaseous state, we have an ion pair which can be considered as sodium chloride molecule. So when liquid sodium chloride solution, that is melted sodium chloride, is again carried out heating at 1413 degrees Celsius, it will convert it into gaseous state. And this gaseous state also we can see ion pairs of sodium and chloride molecules. Whereas in non-ionic compound, the unit of non-ionic compound is again the molecule. Here the weak intermolecular forces will be dipole-dipole interaction and van der Waals forces. Both are weak intermolecular forces that is present in the non-ionic compounds. So these are more readily and the strong interionic forces of ionic compounds, and boiling will occur at very lower temperature. So non-ionic compounds will boil faster, whereas ionic compounds boil at high temperature. They require very high temperature. Example, non-polar methane boils at minus 161.5 degrees Celsius, and the polar hydrochloric, that is HCl, boils at only minus 85 degrees Celsius. Liquids whose molecules are held together by hydrogen bonds are called associated liquids. So breaking this hydrogen bonds takes considerable energy, and so an associated liquid has a boiling point that is abnormally high for a compound of its molecular weight and dipole moment. So hydrogen bond is also very difficult to break. This also requires high energy. Example, if you take hydrogen fluoride boils 100 degrees higher than the heavier non-associated hydrogen fluoride. Similarly, water boils 160 degrees higher than the hydrogen sulfide. So there are some organic compounds that contain hydrogen bonded to oxygen or nitrogen. And here also their hydrogen bond will occur. So due to this hydrogen bonding, their physical property, melting and boiling points, are increased. Let us take, for example, methane. So replace one of its hydrogen with a OH group. So what it becomes? CH4 you had, remove one H and replace it with OH. So it becomes CH3OH, that is methanol. It is the smallest member of the alcohol family. So this CH3OH, structurally it is going to resemble methane and also water. So if you see CH3, if you remove OH and place H, it will be methane. Remove CH3 and place H, it will be water. So it has similarity in between the methane and water, but now it is entirely different, that is alcohol. Like water, it is an associated liquid with the boiling point abnormally high for a compound of its sizes and polarity. When compared to similar compound, it will be having higher melting and boiling points. The bigger the molecules, the stronger will be the van der Waals forces. Other things like polarity, hydrogen bonding, boiling point, these are will be that is polarity and hydrogen bonding will be equal, whereas boiling point will rises with increasing molecular size. So increase in molecular weight, increase in boiling point. The bigger the molecules, the stronger will be the van der Waals forces. So this finishes here intermolecular forces, melting point and boiling point. So any doubts here? Yes, any doubts?
No, ma'am.
Understood what is melting point, what is boiling point? You should know how the melting points in ionic compound, non-ionic compound, boiling point in ionic compound and non-ionic compound. What are the forces they are engaging? Different intermolecular forces like dipole-dipole interaction and van der Waals forces. So we have one more, that is ion-dipole interaction. So the attraction of positive ion for the negative end of a polar solvent molecule and attraction of negative ion for the positive end of polar solvent molecule is called as ion-dipole interaction. And these attractive forces are also called as secondary bonds. They act between different molecules and ions. Individually they are weak, but together they are strong. They are very powerful.
Ma'am,
Yes.
please repeat ion dipole interaction definition once more.
Okay. The attraction of positive ion for the negative end of a polar solvent molecule. The attraction of positive ion for the negative end of the polar solvent molecule and the attraction of negative ion for the positive end of polar solvent molecule. This is called as ion dipole interaction. So this is between an ion and polar solvent molecule. These are also called as secondary bonds. Different molecules, and individually they are very weak, but together they are powerful. An example for this ion dipole interaction. Example you can give. the ion dipole forces between water molecules and sodium ion. So between what the attraction is seen, the oxygen atom in the water molecule has a slight negative charge, and this is going to be attracted to the positive sodium ion. So the positive ion will have attracted towards the negative end of the polar solvent molecule. Positive hydrogens are attracted towards the negative polar solvent molecule. So next we are left with solubility. Solubility, non-ionic solutes and ionic solutes, protic and aprotic solvents, and ion pairs. So we'll discuss this in next class.
Thank you, ma'am.
Save the PPT
Thank you, ma'am.
today.
Thank
Till
you,
today.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am.
Thank you. Bye.